Welcome to the FAA Production Studios and the FAA Safety Team's National Resource Center located in the Sun and Fun Complex in beautiful Lakeland, Florida. Our next presenter is the president of Lockwood Aviation Supply, and he is the only Kodiak authorized master service center in North America. He is the foremost expert on Rotax engines, their care, their feeding, ADs, and surface information for the 2- and 4-stroke light sport aircraft engines. His topic today is the pilot's guide to Rotax engine maintenance. Let's welcome Phil Lockwood.
Well, thanks for the great introduction. Okay, folks, got some great weather here this week. We've been fortunate with that. I'm going to give you some insight into the technical aspects of the 9 Series engines and some current maintenance information. I think you should pick up some good points. I wanted to begin with some of the unique characteristics of the 9 Series engines and why it's different from the typical Lycoming and Continental engines that most of us are more familiar with. First, the 9 Series Rotax has water-cooled heads, and that is what enables it to get so much power out of such a small displacement. Only about 1,400 cc's on a 912S, and so we run it at higher RPM, and that enables us to get a lot of power out of a very compact engine. But most of the heat is in the heads. With the liquid cooling, we can dissipate that rapidly and efficiently. We also have a dry sump, which keeps the engine compact again, and it allows us to run with a very small quantity of oil, relatively small, only about 3 quarts. Because the shape of the oil canister is slim and tall, we know that at a wide variety of angles, we can still get to that oil in the bottom of the canister. Now, one thing you should know if you're going to work on these engines is that it's important that you get the lines hooked up to the oil tank correctly. As you can see from this picture of the top of the oil can, one line goes down to the bottom center of the oil tank, which is your feed line, which goes to the oil pump. Now, in that line, you will find the oil cooler in between the oil tank and the oil pump, and that is, the oil is actually cooled on its way to the engine. Now, you can see from this picture that if you were to actually hook up the oil feed line to the return line on the tank, which comes in at an angle and actually sits above the oil level, which is about here on the oil tank, that would be a mistake. And when you started up the engine, you would not get any oil pressure. And if you continue to run it for more than a few seconds, you could damage the engine. And we have had customers do that, hook it up backwards. So if you're ever in question as to which is the in and the out, even though they are labeled on the tank, the best thing for you to do is actually take the top of the tank off and look at it, and then there's no confusion. Now, one of the other tricks to making this engine very compact is the pressed crank assembly, 5-piece crank. And because the crank parts are machine forged separately and pressed together, there again we can make it very compact. You'll notice in this photo the engine does have plain oil pressurized main bearings and lower rod bearings. Now, we also utilize the gearbox, and the gearbox is essential to the formula that allows us to produce a lot of power out of a very compact engine. Now, in the past, gearboxes have gotten a bad rap in aviation engines, but it's important to note that Rotax began life as a gearbox manufacturer, and it's their expertise in manufacturing gearboxes that has allowed them to produce this lightweight geared engine. With the gearbox part of the package from the very beginning and not an add-on, the aft part of the gearbox is actually cast into the crankcase, and the engine was never envisioned any other way. The gearbox has received a number of improvements over the years, but the current version is very reliable and very durable, requiring service only about every 600 hours, and that service typically only costs about $100 each time around. So you're talking about an hour service requirement. So I would encourage people to not be concerned about that, the use of that gearbox, because it works very, very well, and it is an essential part of making the engine do what it does. Now, because we're geared, we can produce max power with a propeller speed of about 2,400 RPM. We reduce the propeller by a ratio of 2.43 to 1 in the 912S engine. And so there again, that makes the engine quieter, allows us to turn a very large diameter propeller, get a lot of static thrust for these low-speed airplanes, and it's a big part of the equation. Now, the newer engines also include an overload clutch. Now, the overload clutch is often referred to as a slipper clutch, but in fact, it does not slip unless you exceed or approach the maximum torque capability of the crankshaft. So it's really there just to guard the crankshaft in the case of a prop strike. It's really more important on a tractor than on a pusher. And if you have a tail dragger and you are susceptible to a potential prop strike, that overload clutch is pretty handy and it will help protect the crankshaft. Now, it does have a 30-degree set of dogs in there, so actually it allows up to 30 degrees of movement between the propeller and the crankshaft when necessary. And there is friction in that zone. And what that does is it allows the gearbox to absorb the torsional vibration that every engine has without damaging the gears. That's one of the tricks that Rotax came up with to make this gearbox work. And the new gearboxes do go right to TBO. And typically, they just need that basic service where we clean them and inspect them and replace some of the spring washers. But the gears and the shaft and all the major components, they go right to TBO now without any trouble. In the past, if you have, say, a four-cylinder Lycoming, like an 0320 or an 0360, even an 0200, you're producing a lot of power at very low RPM and it's direct drive. So your power pulses are pretty severe. And that's why the propellers on the Lycomings and Continentals that are direct drive have to be so much stronger than the propellers that we get away with on these Rotaxes. Part of the key to our light package is not just the fact that the engine is very light, but the fact that we can use lightweight engines. When we're producing our power at 5,500 RPM with a four-cylinder engine, in effect, we're turning double the RPM of a Lycoming or Continental. So the power pulses are more like that of an 8-cylinder engine than a four-cylinder engine, because they're smaller pulses and there are a lot more of them, and that makes the engine very smooth. It also, because of the fact that they're smaller power pulses and we have this torsional vibration dampening device in the gearbox, the big power pulses don't get through to the propeller, and that allows us to use very lightweight propellers that you couldn't put on a direct drive engine or you would destroy the hub. We also use an aluminum cylinder. Again, something that in the past a lot of people would hear and say, oh, aluminum cylinder, I don't want to touch that. But they're Nicocil coated cylinders, and it's actually not so much a coating, it's impregnated into the cylinder wall. And it is absolutely incredible. I think it's one of the best parts of this engine. The aluminum Nicocil cylinders are very lightweight, of course, because they're aluminum and they're not steel, and they don't have a steel liner. But also, nickel is one of the best metals that we know of today for abrasion resistance. In fact, when pump companies design large slurry pumps designed to pump abrasives like stones or sand in water, they typically will build them out of nickel or line them with nickel because of its resistance to abrasion. And that nickel silicon alloy that is on that cylinder wall makes these things wear like, well, I can't say wear like iron because it's really way better than iron. In fact, we've had engines come into our shop now with over 2,000 hours, like 22, I think the highest one was 2,200 hours, running at 5,500 RPM cruise. And we measure the wear on the cylinders, and I think that one was about a 1,000th of an inch wear total. In fact, the tolerances are so tight that on a new 9 Series engine, the tolerance out of the factory between the piston and the cylinder wall is 0 to 8/10 of 1/1000th of an inch total clearance. There is no break-in, there is no burning of oil. Everything is so precisely machined that you can pretty much figure on about 1/4 of a quart being consumed in 100 hours. And yes, we can go 100 hours between oil change intervals if you're using unleaded fuel. Now, just to emphasize how tight that is, I've taken brand new pistons and pushed them in the cylinder without the rings, and I can turn it upside down and it doesn't fall out. I mean, you really look at it and you go, this can't work, but it does. Now, the other thing is, because they're Nickel cylinders, we don't have to worry about corrosion because they won't rust, and we don't have the shock cooling issues that you have with a steel cylinder and an aluminum piston, because the aluminum piston and the aluminum cylinder will expand and contract together, and so that's why we can hold those very tight tolerances. Now, you might think that why is it that only Rotax has this technology? And some people are skeptical when they hear about me talking about this Nickel cylinder on these 4-stroke engines, and they think, well, you know, if it's so great, then why aren't other people using it? Well, they actually are. Most of the new BMW automotive engines use Nickel cylinders. Porsche has been using it on their engines for many years, and so it's not really something that only Rotax uses. It is an expensive process, and therefore you typically only see it in the higher end automotive industry, but for an aircraft application it is really good. Now, another feature of these engines is an electronic ignition system. We have a completely redundant dual electronic ignition system, which essentially has no moving parts. The flywheel is the only moving part, and of course you have to have a flywheel anyway. So the coils that you see in this slide are actually fixed to the block. And in the flywheel you have magnets that circulate around these coils and excite them, and that's where you get your spark. Now, this ignition system differs from the electronic ignition system that you typically see in your car, in that it is a AC ignition system. Automotive ignition systems run on DC off the battery, and that means that if your alternator should fail in your car, and I've had this happen to me, and you will continue to run off the battery until the battery dies. Now, if you're in the winter time or in the summer where you're running your AC fan, it won't take you long to draw that battery down once you have lost your alternator. And once your voltage drops down somewhere in the 11-volt range, your engine will stop running. That's really not acceptable on an aircraft. So what Rotax did was they made this AC ignition system, and you can see here that 2 of these coils with the red arrow pointing at them are the coils, 1 each, that power the ignition systems. Now, what that means, though, is that the actual energy for the spark is being generated as the engine is running. So when you're starting the engine, it is critical that you get about 240 RPM to have enough rotational speed to create enough spark to get the engine to start. So that is something you have to understand. It's the bad that comes with the good. We do need a strong battery and good connections to make sure the engine cranks over fast enough. And it also makes the engine not really a candidate for prop starting, because we have to crank it over pretty fast. The plus side of that is it's a simple system. There's really nothing, there's not much to go wrong, and it's unlikely that anyone would ever start an engine by accident while turning the propeller over, because you have to turn it over pretty fast. So that's a nice safety feature. Now, those other coils that you see on that stator are to charge the battery. And so what we have, again, instead of having an external alternator where you have belts to worry about and mounting brackets to worry about braking and vibration, our generating system is an AC system that, again, has no moving parts. It's bolted right to the block, and it has an external solid-state device which rectifies that AC current to 14-volt DC. And that gives you a maximum of 18 amps, which is enough for most of the modern light sport airplanes, even with strobes and landing lights and a couple of radios and an EFIS. Most of them can get by with that. Rotax does offer an external 40-amp alternator if you want to carry a lit banner behind you. Automotive spark plugs is another nice feature. If you guys have worked or had a Lycoming or Continental, you know how expensive those spark plugs can be, those special aviation spark plugs. We actually started with aviation spark plugs, and they were like 20 bucks each. And Rotax quickly realized that they could use an automotive style spark plug and that they could still certify the engine with that. So that's what they did. And so the spark plugs are cheap, and we change them every 100 hours on the 912S. There you see the 70, DCPR70 is for the 80 horsepower 912. The 8E is used in the 100 horsepower 912S, and then the Denso U9 is the correct spark plug for the 914 turbo. Now we utilize constant depression carburetors in this engine. They work very well. They have the ability to control the mixture. They actually do lean the engine as you climb, and so there's no need for a mixture control. There isn't a mixture control. So all these engines are a single knob setup. You just have your throttle control, and you're throttling the engine with the butterfly that you see in that left screen there. There is a slide that you can see from the intake side of the carburetor on the right picture, and that slide goes up and down pneumatically via a chamber. There's an airtight chamber in the top of the carburetor which allows that slide to go up and down via vacuum. And what it does is it senses the pressure and it moves it up and down and brings that needle up and down inside that carburetor, and that's what changes your mixture automatically as the density decreases. Pretty nifty. Carburetors do need service. I mean, they need to be maintained and taken care of. If you do a reasonable job of taking care of them and setting up, they work very well. 2 carburetors allow us to get a lot of power out of that little engine. Now, if you have questions, I'd ask you to hold them to the end, and I will leave some time at the end of this presentation to answer questions. There'll be somebody coming around with a microphone. So if you think of a question, try to remember it, and I'll be happy to answer it towards the end of the presentation. On this page from the Rotax website, you can see the small size of this engine here, exactly 1,352 cc's of displacement for the 912S. Quite remarkable, only 82.6 cubic inches in displacement. And that is, again, part of the reason that engine is so small and so light. And what is remarkable, when you look at small automotive engines, and there really aren't that many in this country that are actually that small, 1.4 liters, those engines typically run at 15–20% power output. I mean, that's all they put out. If you open up your car, it's typically only for a short time to sprint up to 60 miles per hour. Then you got to back off on the throttle. You're going to be exceeding the speed limit. And these engines have to be built to run literally wide open. We have a lot of customers that prop them so that they will turn only 5,500 at full throttle, and they run them wide open except when they're on approach to landing and when they're on the ground. The rest of the time they're right to the boards, and they take it. They'll go 1,500 hours like that, provided you keep the oil temperature, cylinder head temperature, coolant temperatures in the green, and maintain the engine properly. Now, also, the engine comes in 2 versions. The 912S is the FAR 33 certified engine. So the engine has achieved full certification, and if you buy that version, it can be placed in standard category aircraft and used for any type of commercial application. What Rotax did was they take the cost that was involved in getting full certification and in keeping the paperwork trail that's required for those certified engines, and they only make the people that need the additional advantages that you can get from a fully certified engine to pay for those. So it's about $5,000 more if you want a fully certificated engine. If you're going to use the ASTM compliant version, which is what most of the